Alright, so let's start off talking about joints. Most of this is review from lab, but I want to get it out there anyways. What is a joint? Anytime you have two bones that meet together, what you have is a joint. Two bones that are connected to each other. Doesn't really matter what's connecting them, but joints fall into four major classification categories, depending upon what is connecting them together. Bony joints is where you have two bones that are connected together by more bone. Fibrous joints are where you have two bones that are connected together with some sort of fibrous connective tissue, usually a dense regular or dense irregular connective tissue. Cartilaginous joints are where you have two bones or more that are connected together with cartilage. And synovial joints are the most complicated joints. They're probably what most people think of when they think of a joint. This is where you have two bones connected to each other by a joint capsule, where they're actually going to be separated by space, and then they'll have this complicated joint capsule structure that will hook them together, and that it, with possibly some ligaments and some fibrous connective tissue involved. So first off, bony joints, which are called synostoses, from syn, meaning together, and osto, like osteo, meaning bone. So this is, bone is bringing them together. It's an immobile joint. It doesn't move. You have two bones, basically, that are fused. There are a few bones in our body that we think of as being one bone, but they're actually multiple bones fused together. So, for instance, your frontal bone, as you can see here, like you think of your frontal bone as being one bone, actually starts out as two bones in an infant. It kind of has to be two bones in an infant because that allows the infant's head to sort of collapse to be small enough to squeeze outside of the birth canal. The mandible also starts off as two bones with a cartilaginous linkage in between them, and those fuse to become one bone. So that's a bony joint. Two bones, your left and right mandible, are connected with cartilage first, and it's a cartilaginous joint at that point, and then that cartilage is replaced with bone, and then it becomes a bony joint. Fibrous joints, or synarthroses, or synarthrodial joints. This is where you have two bones, or a bone in a bone-like structure, bound together with dense connective fibrous tissue. There are three types of fibrous joints: Gomphoses, Sutures, and Syndesmoses. Gomphoses, these are sort of the odd man out. This is the attachment of a tooth to a bone, usually the tooth socket, and it's being attached by fibrous connective tissue, dense, regular fibrous connective tissue, called periodontal ligaments, which you can see here. It's a periodontal ligament. That there. These are all periodontal ligaments that are connecting the tooth to the bone around it. Gomphoses are only found in the connection of tooth to bone. They allow the tooth to have a little bit of mobility within its socket, so that it doesn't take so much damage when you're using it to chew, or if somebody gives you a good knock on the head and manages to hit a tooth. Sutures. Sutures are where you have two bones come really close together, and then you have dense connective tissue, which is going to hold them really tightly close to each other, Most sutures are found in the skull, and there are 3 classifications of sutures based on the type of joint that they make in sort of a woodworking sense. So up here you see this is a serrate suture. Serrate, you think serrated blade, it means a wavy line. That wavy line is going to increase surface area. More surface area means that you have more connective tissue holding them together. It means that it's a stronger joint. So you can see down here, the serrate suture is roughly the equivalent of a dovetailed joint, which does maximize surface area. Lap or squamous sutures. So you can see here in the temporal bone. So we have a lap suture. With a lap suture, you have one bone which will overhang and the other bone that will underhang, and they form a diagonal. That diagonal has certainly more surface area than a straight connection would, so it does increase surface area. It's also going to provide a nice solid surface where this top bone here can't be forced down, so it gives a nice solid area there. Last, we have a plain suture or a butt suture. This is where you just have 2 bones butt up against each other, and then you got some tendons stretching back and forth, or some connective tissue stretching back and forth. Makes the weakest of the 3 sutures, and is usually going to be used for structures that don't come under a lot of stress. So, for instance, you can see here between, your 2 maxillae, that you have this plain suture between them. You're really unlikely to take a blow to that part of the face. Last fibrous joint type is a syndesmosis. This again comes from syn, meaning together, and in this case, desmo means connection, as in connective tissue, right? 2 things that are held together by connective tissue. In this case, it's going to be by a broad sheet of dense fibrous connective tissue, like mostly regular connective tissue. An example of a syndesmosis is going to be the interosseus membrane, right? So here we have, actually in this case, this is the fibula on this side. And, well, no. Yeah, this is the fibula on this side, and this is the tibia on this side, and you have this dense fibrous connective tissue in between them, and that's holding the bones together so that they can't, fall apart. You have a somewhat looser interosseous membrane between your radius and ulna, and that basically keeps your radius and your ulna from getting displaced from one another, from being moved relative to one another too much. But it's loose enough that it can allow your radius and ulna to twist relative to each other, which allows you to supinate and pronate your arm. Third category, cartilaginous joints. There's 2 categories of cartilaginous joints depending upon the type of cartilage that's holding them together. There's synchondroses and symphoses. Synchondroses have bones joined together with hyaline cartilage. These are typically temporary joints. It comes from syn, together, chondro, cartilage. As we know, hyaline cartilage is the predecessor of bone and can become bone. So usually these are going to start off as cartilaginous joints with hyaline cartilage in between them. That hyaline cartilage will ossify into bone, and it will then become a bony joint. So the the top joint between your first rib and the breastbone. That has hyaline cartilage there connecting the two bones together. That can ossify over time. Usually you have to be pretty old, but it can ossify over time and actually join together. We talked about, you start off with two frontal bones, two mandibles, and those are started off as cartilaginous synchondroses. And then in early childhood, that cartilage ossifies and they become bony joints. A symphysis is a permanent structure where you have two bones joined by fibrocartilage. There are two main types of symphyses in your body. The pubic symphysis, which is the area down here where your two pubic bones meet, and there's a plate of fibrocartilage there. The other type of symphysis is your intervertebral disc, which you see here. There is a plate of fibrocartilage in between each of your vertebrae, and that allows a little bit of articulation, not a ton, but you've got a lot of them, so it adds up. And mostly it's actually really good at resisting impact. Your spine has to take a lot of impact as you walk. Your hips bear the weight of your entire upper body, and all of that weight is transferred to your pubic symphysis, where it's basically absorbed there. Last joint category is a synovial joint. This is the most mobile type of joint. Bony joints don't move at all. Fibrous and cartilaginous joints have very limited movement. Synovial joints have extensive movement. This is where you have two bones which meet together with articular cartilage ends, typically hyaline cartilage end, and that hyaline cartilage is there for a reason. It is to stop the bone from rubbing against bone. When bone rubs against bone, it does damage. Like, you get little pieces of the bones that break off, they rub against each other, they become inflamed. That's painful and dangerous. Cartilage is smoother than bone, so when cartilage rubs against cartilage, you just simply have less damage that's done. It's softer, it has more give. But even then, like, having cartilage rub against cartilage is not the ideal situation here. These two cartilage-covered ends are held together in a complicated structure called a joint capsule. The joint capsule is made of fibrous tissue on the outside, which is contiguous with the periosteum. The periosteum of one bone basically lifts up, wraps around to the bone that it's jointing into, and then becomes the periosteum of that. That gives it strength. That's the fibrous outer layer. And then on the inner layer, you have a membrane called the synovial membrane. This is a thin layer of cells that excretes a special fluid called synovial fluid. This fluid is slippery and viscous. It has about the consistency of egg whites. It's rich in albumin, which is actually one of the proteins found in egg whites, and hyaluronic acid. It is rich in nutrients, rich in oxygen, and it acts as a lubricant to keep these bones from actually rubbing against each other. It makes the same sort of, it has the same sort of function in your joints that engine oil does in your engine, right? It's going to allow surfaces to slide past each other without generating heat, friction, and damage. The synovial fluid also has the job of nourishing your articular cartilage. Remember, cartilage is very poorly vascularized. It doesn't have blood vessels going into it, feeding it oxygen and nutrients. So the synovial fluid is actually what's going to give oxygen and nutrients to your cartilage. So in general, there are some accessory structures to your joints as well. So tendons, which are collagenous tissue, usually dense, regular connective tissue that attaches muscle to bone. Ligaments, which is dense, regular connective tissue that attaches one bone to another bone. A bursa, similar to a joint capsule, this is a fibrous sac filled with synovial fluid, and it serves that same lubrication function. This is going to be found in areas where you have moving things, particularly you have tendons moving past muscles, or tendons passing over bone. And if they were just rubbing against each other, it would create friction. It would create damage and inflammation. That would be bad. It would have long-term negative consequences. The bursa is this lubricated area in between them. It's this enclosed lubricated area in between them. The tendon will then flow through the bursa, not directly contacting the bones or muscles that are near it, and that synovial fluid will kind of grease its way through so that it can move back and forth without doing damage or generating a lot of heat. A tendon sheath is effectively a bursa that goes, acts as a cylindrical tube that surrounds an entire tendon. It's found mostly in the tendons that control your fingers, whereas bursas are located all over the body. Articular discs. This is the fibrocartilage pad that's found in any symphysis joint. Never mind. The articular disc is the fibrocartilage pad between articulating bones, and it crosses the entire joint capsule. So, for instance, in the temporomandibular joint, this is the joint between your mandible and your temporal bone. There is a pad of fibrocartilage there that exists to absorb shock. Like, basically, your jaw is actually one of the stronger muscles in your body. And as you, bite and really chew into something, pressure and impact are exerted on that, on the temporomandibular joint, and that fibrocartilage exists to absorb that shock. Similarly, the meniscus is a fibrocartilage pad found in the knee. It's a semilunar, sort of crescent moon-shaped pad, and it exists to absorb shock and impact from every time you take a step. They stop the bones from running into each other. They absorb impact forces, and they allow you to continue walking through most of your life with relatively little damage done to your knee. So here you can see an example of a bursa. This is that fluid-filled bursa with the synovial fluid in it, and it's guiding these tendons in your hand through the wrist in the carpal tunnel area. And without this bursa being present, all of these tendons moving back and forth constantly every time you move your fingers would eventually start to tear up the area. Last thing that I want to talk about is the role that exercise plays in joints. Exercise is actually super duper important for joints. There's a few reasons, like you've probably heard of warm-up exercises, and these are literally warm-up exercises. Just like on a cold day, you go out and you start your car and you let it warm up for a while before you drive it. That warms up the engine oil. Engine oil gets really thick and sticky and solid when it's cold. And so you want it to be warmed up so that it's nice and fluid and actually doing its job before you drive your car away. It's the same with synovial fluid. Synovial fluid, when it gets cold, it gets thicker, more viscous, and it doesn't do its lubrication job as well. So exercise generates heat. You're burning energy that generates heat. And that heat heats up the synovial fluid, and when synovial fluid is warm, it acts as a better lubricant to the joints. In addition, when it's thinner, it's more easily absorbed by the cartilage. That's the other thing that synovial fluid does, is it nurtures the cartilage. When you do exercise, like medium impact exercise, what you're basically doing is you're creating impact on your articular cartilage that squeezes it. And you think of like a sponge, right? So you squeeze the sponge, fluid rushes out of the sponge, you stop squeezing the sponge sucks fluid back in. Every time you have like a repeated impact on the articular cartilage of one of your synovial joints, it squeezes the cartilage a little bit, cartilage squeezes out old fluid, and then when you relieve the pressure, it sucks in new fluid. This is the only way your cartilage actually gets nutrients and oxygen and things like that. It doesn't have any blood vessels to take it in there, so this kind of like medium impact exercise is really important for maintaining cartilage health. It squeezes fluid and metabolic waste out of the cartilage. When the weight is removed, the cartilage absorbs the synovial fluid, taking oxygen and nutrients in. Without exercise, your cartilage deteriorates and dies, resulting in arthritis and poor joint health later on in life. So, just to reiterate, joints are any time two bones meet and are connected together. There are 4 joint types: bony, fibrous, cartilaginous, and synovial. You should know what distinguishes them and be able to classify joints into these categories. So if I say 2 bones held together by bone, that's a bony joint. You should know the 3 types of fibrous joints: Gomphoses, Sutures, and Syndesmosis. So if I say something like, this type of joint holds a bone to a tooth, then you should answer Gomphoses. There are 2 types of cartilaginous joints: synarthroses and symphyses. Synarthroses are usually temporary. Symphyses are extended structures. They're permanent. You should know where they're found. You should know the differences between them. You need to know what a synovial joint is. Its accessory structures: ligaments, bursa, tendon sheaths, the joint capsule, the synovial membrane, and the cartilaginous pads, meniscus, things like that. You should know what those are, what role they play, and you need to understand what role exercise plays in cartilage health at synovial joints.